we're trying to solve for x in the exponent, and the first thing we notice with this one is that we could give them a common base, because 25 and 125 are very similar numbers. In fact, 25 is the same as 5 squared, and 125 is the same as 5 cubed. So I could just rewrite these as 5 squared and 5 cubed. So instead of writing 25, I now have 5 squared to the 3x. And instead of writing 125, I now have 5 cubed to the x plus 2. And now we have exponent rules, and we know that our exponent rules tell us when we have two exponents like this, we can just multiply them together. So I end up with 5 to the 6x, because 2 times 3x is 6x, equals, and then I just multiply these together. So that's 5 to the 3x plus 6, because I need to use the distributive property to multiply the 3 by the x and by the 2. So now I have a common base, and so I can just set their exponents equal to each other. So I can say 6x has to equal 3x plus 6 because they had a common base. So I subtract 3x from both sides and I get 3x equals 6. Therefore, x equals 2. Now this one might look a little bit trickier because it doesn't have an apparent common base, but let's think about, this has a base of 10, so can I write this other one as a base of 10? Well, let's see, 10 to the 0 is 1, 10 to the 0 is 1, 10 to the negative 1 is 1/10, which is also written as 0.1, right? And then 10 to the negative 2 is 1/100th, which is also written as 0.01. Okay, that's 1/100th. So 10 to the negative 3 is 1/1000th, which is 0.001. Okay, so 1/1000th is equal to this, which is also 10 to the third. So I can rewrite this as 10 to the negative third. That's 10 to the negative third. And so now we have that equal to 10 to the 6x. So they now have the same base, right? One has a base of 10, the other has a base of 10, and we can set their exponents equal to each other. So negative 3 equals 6x. And so we divide both sides by 6. And we get x equals negative 1/2. And that would make sense, right? Because if I put negative 1/2 in for x, I'd get 6 times negative 1/2, which is negative 3. So if I did this, 6 times negative 1/2, I would end up with 10 to the negative third, which is exactly what I wanted in the first place.